Hello! We're going to be looking at some simultaneous equations in this video, both linear and quadratic. So I'm going to go through 4 different examples. Feel free to pause at any point and have a go at the questions yourself. So in this first one, you've got 2 linear simultaneous equations. We know they're linear because we haven't got any squareds or cubes in there. The highest power of A and the highest power of B are both 1. So what I'm going to do first is I'm going to check to see if any of my coefficients are the same. Coefficients are just the numbers in front of the A or the B or the X or the Y. So my A's are definitely not the same. My B's are pretty similar. The only difference here is that I've got a positive 4 and a negative 4. So if I've got 2 coefficients that are the same, I have to do a little bit less. Because I've got a positive 4 and a negative 4 there, I just need to figure out whether I need to add or subtract to eliminate the B's. So I can just do a quick little trial here. If I did plus 4 minus 4, if I chose to subtract the 2 terms, I would end up with plus 4, and a minus and a minus together give me a plus, so I'd end up with plus 4, which is equal to 8. So that's not going to eliminate my B terms. So instead, subtraction didn't work. I'm going to have to add them. So what I'm going to do, I'm going to label these 1 and 2, and I'm going to add equation 1 to equation 2. So 3a plus 2a is equal to 5a. 4b plus negative 4b is going to cancel out, which is exactly what I want. And then 23 plus 2 is equal to 25. And from there, I've got a much simpler equation with just one unknown value, so I can solve for a. So if I divide both sides by 5, I get 25 divided by 5, which is 5. There's my value of a, and then I need to go back to find my value of b. So to do that, I can pick either one of my equations. I'm just going to go for equation 1, which was 3a plus 4b equals 23, and I'm going to substitute in my value of a. It shouldn't matter which equation I go for, because ultimately I'm finding a value of a and a value of b that fit both equations. So whichever equation I choose, I should get the right value for b. So 3 times by 5 plus 4b equals 23. That gives me 15 plus 4b equals 23. And I'm just going to rearrange here to solve. So I'm going to start by taking away 15 on that side. 4b is equal to 23, take 15, which is 8. And then I'm going to divide both sides by 4, so b is equal to 2. So there are my 2 solutions. A equals 5 and b equals 2. So that's that question done. Let's try another pair of linear simultaneous equations. So this time, looking at my coefficients of x and my coefficients of y, neither one is the same. So I'm going to have to scale them to make either the x's or the y's the same. Now, sometimes you'll find that one set is going to be easier than the other. For example, if I had a 2y and a 4y there, I'd go for that one because it's easy enough just to double one of them and get the other, but that's not really the case here. So I'm just going to pick, I'm going to decide to go for my x's, and I'm going to change them so that they are both 12x. So I'm going to multiply that by 4 and that by 3, and I've then got to do the same thing to the entire equation. So 3x times by 4 is of course 12x, 2y times by 4 is 8y, and this is often where I make silly mistakes, so just make sure that you're not making those silly mistakes yourself. 4 times 4 is equal to 16, 4x times by 3 is 12x, 5y times by 3 is 15y, and then 17 times by 3, I believe, is 51, but I'm just going to double check that on my calculator. Yes, it is. So now I've got my coefficients of x, the numbers in front of x being exactly the same. I'm going to label this equation 1 and that equation 2. And again, I need to decide whether I need to add or subtract. So if I was to add these together, 12x plus 12x would give me 24x. That's not really going to work for me, so I'm going to subtract them this time. So equation 1, take away equation 2. You can, of course, do equation 2, take away equation 1. Doesn't really matter. I'm just doing them in the order they're written here. So if I subtract those, 12x take away 12x is nothing. 8y take away 15y is going to give me negative 7y. Be careful with your negatives here. And then 16 minus 51, again, I'm going to end up with a negative number, which is negative 35. So from there, I need to solve for y. I'm going to divide both sides by negative 7, which gives me 5. And then again, just like in the previous question, I'm going to pick any one of these equations. Again, I'll go for the top one. So 3x plus 2y equals 4. And I'm going to substitute in my value of y. So 3x plus 2 times 5 is equal to 4. 3x plus 10 equals 4. I'm going to take away 10 on both sides. 4 take 10 is negative 6, and then I'm going to divide by 3, so x must equal negative 2. Therefore, my solution is x equals negative 2 and y equals 5. So that's how I would solve my linear simultaneous equations. Let's go ahead and have a look at ones where you have a linear and a quadratic. So here's your example of a linear equation there and a quadratic. It's a quadratic, of course, because it's got the x squared. So the first thing I'm going to do here is I'm going to make either my x or my y the subject so that I can substitute it in. You'll find that simply adding or subtracting won't work here. So I'm going to just rearrange that. And the easiest thing to do is to move my negative x over and make it positive. So I get y equals 10 add x. And now what I can do is, because this equation is equal to y and that equation is equal to y, y must equal y. Therefore, x squared plus 3x plus 7 must equal 10 add x. And the reason why that's quite helpful to do is that I now just have one unknown. I've just got the x's that I need to solve. So this is called solving by substitution, because what I've done is I've substituted one equation into the other. What I'm going to do now, I can see that there's a quadratic there, and I know that with my quadratic equations, I always have to make them equal to 0 first. So I'm going to move everything over and change the signs. That's going to give me x squared plus 3x plus 7, take away 10, take away x equals 0. And then I'm going to simplify that by collecting my like terms. So I get x squared plus 2x and 7 take 10 is minus 3. And then because I've got a quadratic here, I can solve it by factorizing, completing the square, or using the quadratic formula. I'm trying to do this without a calculator, so I'm going to factorize that because it does actually factorize very nicely. So two numbers that multiply to give me 3 have got to be 3 and 1. The product is negative, which means one of these two has to be negative, and I want it to add to 2, so it makes sense to make the 3 positive and the 1 negative. So from there, each of my brackets is equal to 0, so either x plus 3 equals 0 or x minus 1 equals 0. Here, x would have to equal negative 3. Here, x would equal 1. Okay, and then I have to do the same thing as I was doing before. I need to go back and substitute these into one of my equations to get my value of y. Now, the easiest equation to work with is probably one of those two. I'm going to go for that one. So y is equal to 10 add x. So I'm going to do 10 plus minus 3 here. And then here I'm going to do 10 plus 1. So here I've got y equals 10 plus minus 3, which is the same as 10 take away 3, that's 7. And then here 10 plus 1 is equal to 11. So my two sets of equations here, I've got x equals minus 3 and y equals 7, or x equals 1 and y equals 11. Make sure you give both pairs of solutions. Let's have a look at one final example, making it a little bit more challenging. So again, we've got a linear equation and a quadratic. Again, I'm going to start by making either my x or my y the subject. Doesn't matter which one, but one of them is easier. In this case, again, the y is easier because with the x, I would have to divide through by 6. So I'm just going to move my y over and make it positive. That gives me 6x minus 14 equals y. And then this time again, I've got all of that which is equal to y, and I've got a y right there. So I'm going to replace that y with my 6x minus 14 because I know that y is equal to 6x minus 14. So I'm going to get 3x squared minus 2, and then instead of writing y, I'm going to write 6x minus 14 equals 19, and then again, I'm just going to simplify. So 2 times negative 2 times 6 rather is minus 12x. Negative 2 times negative 14 is 28. And that's equal to 19. And again, I've now got one equation with one unknown. It's a quadratic equation, so I've got to make it equal to 0. So I'm going to move that over and subtract it, which gives me 3x squared minus 12x, and 28 minus 19 is equal to 9. So positive 9 there equals 0. So again, I've got a quadratic equation I can solve by completing the square, factorizing, or using a formula. I'm going to try factorizing first. I've got a common factor there of 3, so I'll take that out. And then it looks like it will factorize further, so I don't have to worry about using the formula, and I can stick to doing this without a calculator, just in case this is on a non-calculator paper. So I need two numbers that multiply to 3. It's got to be 3 and 1 again, but this time the signs have to be the same because I've got positive product, and they have to add to negative 4, so it's got to be negative 3 and negative 1. So again, either x minus 3 equals 0, in which case x equals 3, or x minus 1 equals 0, in which case x equals 1. And then finally, I'm going to do the same thing I've been doing all along, take those values and substitute them back into one of these equations. Let's go for that one. Y is equal to 6 lots of x, take away 14 there. Same thing here, y is equal to 6 lots of x, take away 14. So here we've got 18 take away 14, therefore y is equal to positive 4. And here we've got 12 take away 14, so y is equal to negative 2. So when x equals 3, y equals 4, or when x equals 1, y equals negative 2. Again, making sure that you have both pairs of solutions. So that is simultaneous equations.